This mini lecture is about chair-chair interconversions, and I've got this movie that I've taken from YouTube. And what we'll do is we'll play it in full screen. Now before we get started with it, let me make a couple of things clear. Look at the blue atoms first. These are what we call axial hydrogens, and the reason for that is because this is the plane of the ring, and these are sticking up and down relative to the plane of the ring. The plane of the ring is where my mouse is going right now. The red ones are what we call equatorials because they're sticking outwards from the ring and they're kind of like around the equator of the ring. Now those are also sticking up and down as well, but just a little bit up and a little bit down. Like this one's a little bit down, this one's a little bit up, this one's a little bit down, this one's a little bit up, this one's a little bit down, this one's a little bit up. Alright, let's take a look at the interconversion itself. And what happens is that it turns into what we call a boat form, and then it twists, and we get our other conformation, which now has the reds axial and the blues equatorial. Boat again, blues axial, reds equatorial again. Now what I want you to do is I want you to focus in on this blue atom here, and let's follow what happens to it as we go. Presently it's in an axial position sticking upwards. Let's have a look and see what happens as it interconverts. There it is, axial up. Ring is converting. Equatorial, still sticking up. Alright, keep your eye on it. Look what happens again. Ring is converting. Blue is now axial, sticking up. So what's happening is that anything that was axial becomes equatorial, anything that was equatorial becomes axial, but they still maintain their same position relative to the plane of the ring. Anything that's sticking up remains sticking up at all times, but just converts between being axial and being equatorial. And there we are, back to where we started.